Hey YouTube, welcome back. Tired of waiting for data? In today's fast-paced world, no applications are death sentence. But what if there was a way to make your data retrieval incredibly fast? Enter caching, the in-memory express lane that can dramatically speed up your application. Okay, let's try to understand the power of caching. Imagine this, your application needs some data. Let's get the pin. The application needs some data. Okay. It will take it from all the time from the database. But instead of making a potentially slow trip to the database every single time, caching will store the frequently accessed information in a super fast in-memory layer. Think of it as having readily available copy right next to your application. When the application needs that data again, it can grab it from this cache almost instantly. This drastically reduces the number of trips to slower database, leading to response times that are often orders. It's orders for it's magnificently faster. Also, you reduced the load on the database because the application doesn't have to go all the time to the database for any data it needs because it stores the frequently accessed data in the cache now. Okay, let's try to understand how caching is implemented. We said before, what is the power of caching? It was pretty easy introduction. If you need more in-depth introduction, we can create this video for you. So caching, I would say, caching is implemented in maybe multiple ways. Let's talk about these four most famous ones. First, we have cache aside. Cache aside is actually this example we have here. It's a very common pattern where the application itself is responsible for checking the cache. If the data exists in the cache, we call this a cache hit. It grab it and serve it to the user. If it's not there, we call this a cache miss. So the application will fetch it from the database and store it in the cache for future use. The application fetches it from the and the cycle continues. Next we have we finished this. Next we have local in-memory caches. Your individual application servers can have their own local caches stored directly in their memory RAM. This provides the fastest access, but the cache data isn't shared across multiple servers. Next we have distributed cache systems. For application running on multiple servers, distributed caching systems like Redis and Memcached are inevitable. These are separate high-speed performance in-memory data stores that can be accessed by all your application instances, ensuring data consistency across them. Lastly, we have content delivery network. For web applications, CDNs are crucial for caching static contents like images, videos, CSS, and JavaScript. These CDNs have often called edge servers, strategically located geographically closer to users around the world. When a user requests the content, it's served from the nearest CDN edge server, significantly reducing load on your origin servers and database and improving loading times for users. Next, we have when to embrace caching. So when we should consider leveraging the power of caching. The first thing, frequently accessed data. Caching shines when the same data is requested over and over again, like a user profile, product catalogs, or popular e-commerce site, or the results of a common search queries. Next, in the ultra low latency needs. If your application demands incredibly fast response times, especially for real-time features for interactive elements, caching is often essential. Next, we can use it for high read traffic. If your database is struggling under the weight of numerous read requests, caching can significantly offload those queries, preventing your database from becoming a bottleneck. Also, you can use them for static web content. For web application, using CDNs to cache static assets is indispensable for improving websites loading speeds and reducing server load. Okay, let's talk about one of the most, however, the biggest challenge with caching is dealing with stale data. If data is if data in the underlying database changes, but the cache isn't updated, users might end up saying outdated or incorrect information. This where cache invalidation comes in, and it can be quite complex. Some common strategies include, for example, using a time to live, like setting an expiration time for cache data. After this time, the cache entry is considered stale and will be refreshed on the next axis. Next, we have write-through cache, the updating cache whenever the database is updated, ensuring data consistency, but potentially adding latency to write operations. We have a write back. Basically, this updating the cache immediately and updating the database asynchronously, improving write performance, but increasing the risk of data loss if the cache fails before the database is updated. There are many other more announced strategies as well, and choosing the right one depends heavily on your application's specific needs and data consistent requirements. And I will create a specific playlist that only talks about cache by I guess after I finish talking about database. I don't know, like maybe I have database. After that we will talk about networking. After that we talk about cache. Sure. But like we will go in depth with caching. So we want to talk about the trade-offs. So beyond stale data, there are more other considerations with caching. For example, memory consumptions. Caching requires additional memory RAM to store the cached data. At scale, this can become quite expensive as RAM is generally more costly than disk storage. Number two, we have not ideal for write-heavy applications. Like since caching primarily optimizes read performance, it doesn't provide as much benefit for application um, um, with write-heavy workloads, where the focus is on quickly and reliably store new data. Okay, so in conclusion, so caching is a powerful and essential technique for building fast and responsive applications. By strategically storing frequently accessed data in memory, you can significantly reduce database load and provide a much smoother and faster experience for your users. Just remember to carefully consider your caching strategy and how you will handle data invalidation. So yeah, have you implemented caching in your application? What strategy have you found most effective? Share your experience in the comment section below. If you found this video helpful, please like, subscribe, and hit the notification bell so you never miss any video. And yeah, thanks for watching.